Alright, time for solutions for homework 9. It looks like this. Alright, number 1, let's get started. We need to distribute this negative through. Okay, remember, our goal is to get x all by itself on one side of the equation. And so we got x inside all these parentheses things. We need to get it out and then get all the x's on one side and all the numbers on the other. So to get stuff out of the parentheses, you have to distribute. So we'll distribute on the left side here, and we'll distribute on the right side. Left side, negative times 2 is negative 2, and negative times negative 3x is positive 3x. There's an invisible 1 out here, and so if you want to think of it as negative 1 times 2 and negative 1 times negative 3x, then that's another way to think about it. On the right side, we got 3 times 2, which is 6, and 3 times 1. 1x is 3x, and then on the end, we still got the subtract 2. So don't forget about the stuff outside the parentheses. It's still there. Now, what I'm going to do, instead of start moving stuff between the sides, I'm going to simplify each side, because I see things that can combine. I can combine like terms. So I'm going to combine these items here. 1 minus 2 is a negative 1, and I got plus 3x. 6 and negative 2 can combine. 6 minus 2 is 4, and then you got add 3x. Okay, now I need to pick a side for my variable. If I pick the left side, then I have to move the variable on the right. If I pick the right, then I move the variable on the left. I'm going to pick left side because I can. So I need to move the 3x on the right. I'm going to subtract 3x from both sides. And if you notice, here on the left side we got negative 1. 3x minus 3x on the left is 0x. There's no more x's on the left. And there's no x's on the right. We just got the 4. And we're left with this part. If you get to a part where there's no more x's, look at the equation. Is this true? Is negative 1 the same thing as 4? If you answer no, then there is no solution. And that's what we got here. Negative 1 is not equal to 4, so we have no solution. If those numbers were the same, then we would have infinitely many solutions. It would be any number you want to put in for x, and it would still be true. Okay. Next item, we got number 2. This one is a compound inequality and has a little or in the middle. Okay. This or tells us that at the end, when we get to our final graph and our answer, anything that is shaded is what's part of our answer. Okay, compound inequalities. With compound inequalities, you have 2 inequalities that you need to solve for. Okay, so we're going to split this into our 2 inequalities. Left side, we got x is greater than 2x minus 3. I'm going to move my x's on the right side, so I'm going to subtract 2x from both sides. Because I don't want my variable on the right, I want it on the left, and the left already has only just a variable. So we'll move the variables on the right to the left by subtracting 2x. X minus 2x is negative x, and we got greater than negative 3. We still need to get x all by itself, but it's got this negative out front. So we're going to divide by negative 1. Divide by negative 1. When you divide by a negative, you have to change the direction of your inequality sign. So x is going to be less than, on the right side, negative 3 divided by negative 1 is positive 3. So x is less than 3. On the right side, we got to subtract x from both sides, because I'm choosing to put x as my variable on the left. You don't have to, but I noticed that on the left, I have just a variable anyway, and so I'm going to put all my variables on the left, and then I don't have to move non-variable things anyway. So left side 2x minus x gets you x. The greater than is still there, and we got negative 3. There's nothing in front of x, so we're all done. Yippee! Yeah, I know. So now we're at a point where we can graph this. So you should start out with a number line, like so. Put down a 0. I notice I need to do negative 3 and positive 3, so I'm going to go both directions and put 0 in my middle-ish section. 3 is here, negative 3 is over here. Okay, and you're going to graph both of these things. Let's start with our left side. We need to put a circle at 3, because that's our critical number here. And this says x is less than 3, so I need to shade the numbers that are less than 3. Shade, 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 and it goes left. Okay, right side equation. Here my critical number is negative 3, so I'm going to put an open circle there. It's going to be open, and I'm not going to fill it in because it doesn't, the inequality doesn't have a line there at the bottom. It's not there, so I'm not going to fill in the circle. So now you got your circle down. Read the statement. It says x is greater than negative 3. So I need to shade the numbers that are bigger than negative 3. So I'm going to shade to the right. And if you notice, the shading keeps going. It keeps going on forever. It goes past the other circles. It keeps going. So really everything that got shaded here is the entire number line. It's the whole thing. And so since I'm in an OR situation, for my answer, my answer is going to be anything that got shaded at all. Well, everything got shaded. And so you can write this in a few ways. You can do negative infinity to infinity with parentheses like that. Or you can just say all real numbers. And we haven't really talked about that. We haven't run into it yet, but now we have. It goes from negative infinity to positive infinity. It's everything. Or you can just say all real numbers. And that should be it for number 2.